All right, welcome back. This would be part two of lesson 1.2.3. So now we want to examine the g of x graph at the right. And so if you notice quickly, like the first thing that should come up is that the function has no errors. I'm sorry, no arrows at the end. So right there has a couple of dots and that's it, right? So that means that we have a function with a limited domain and range, all right? So limited domain and range. So pretty much that means that it has a stop, right? It has a start and has an ending. So for sure, when we're looking at the graph in this case, right, is g of x a function? So again, let's determine that. How can we tell? Again, all we have to use is a vertical line test, and then if we draw a vertical line anywhere on the graph, if you notice, it only touches once again. So pretty much we can consider that this is a function. Again, it is a function. It passes a vertical line test, right? All right. And then this next question would be, which x values have points on the graph? That is, what is the domain of g of x? So if you notice, we start pretty much on the farthest left right here, all right, which is at -2. So that's our farthest left. And then if we go all the way to the right, if we keep going this way, just looking at the x values, that's what matters to us right now. If we look at that, if you notice, we stop at +4, right? So we start, and then we stop at +4. So this is pretty much the domain of our graph, right? And now, if you notice, there is a big difference, right? We probably have seen this before. If you have a circle, open circles at the ends, right? If you have a line, or if you have two closed circles at the end, right? Or if you have arrows, or even a combination of any of these, you can have a circle and then a closed one at the end, or you can also have like a closed circle and then an arrow, and so forth. All right. So any combination of the three main ones. So pretty much, if you see the open circle at the end, that means that you don't include the endpoints. All right. So you can also sometimes see these. You'll see the open parentheses. That's what we call them. All right. And then the next one, if you see the closed circle or the closed dots at the ends, like we see in this one, we use what we call the closed brackets in math. All right. This is all notation, so make sure you guys are taking a clear note of this. So open parentheses, if you see the parentheses, that means the open circle. That means you do not include the endpoints. And then the closed brackets means you include the endpoints. All right. And then the arrows, you would pretty much use a parentheses as well, but that means that it never stops. So never stops in either direction. And this one, if you do have a start and then an arrow, that means it starts somewhere, but it never ends. So that's a big difference. So here, if you notice, we have two closed ones. So we would use pretty much the closed brackets. And then you can just put a comma in between those two. So what are the possible outputs of g of x? So this is called the range of the function. So when we see those are called the range, which is the y values of the function. All right. So now we're looking at the vertical. So we're looking to see what's the lowest points and then what's the highest point. So if you notice right there, our lowest point happens to be at 1. And then our highest point over here on the graph happens to be at +3. So we start at our lowest, which would be -1. So that's our start for the range. All right. It's -1. And then our stop is at, in this case, +3. Now, if you notice, we do have a closed circle there, so we would include the value. So that would be a closed bracket, the square bracket, and then comma. And then the other one would be pretty much the top one. Since it is part of the line, If you see it's part of the line, then you would use pretty much also the square bracket. And then it says Ricky thinks the range of g of x is negative 1, 0, 1, 2, and 3. Is he correct? Why or why not? So pretty much I would say that he is correct in the range, right? Because it does negative 1 and then 0, 1, 2, 3. Those are all values that are included as part of the graph. But if you notice, there's also the values in between. So it's not just those three numbers. It's all those and everything in between. So we would say he was partially right. All right. And then let's look at the next set of problems pretty much. So work with your team, or in this case, work with yourself to describe the domain and range of each graph and then state whether it represents a function or not. So pretty much again, if you look at the first one, so start with a domain. So domain, remember, goes left to right, and then the range goes up and down, right? So here, if we start to our leftist value and then our rightist value, and again, it's part of the line, so we're going to use the square brackets for both of these, and then comma. So we start at negative 3, and then we stop at positive 3. And then if you look again at your range, again, what's your lowest value, which is again negative 3, and then you go all the way up and you end up at positive 3. And then we want to know whether this is a function or not. And then the easiest way is if you draw a vertical line, what happens? And if you notice in this case, it intersects at 2 points. So again, if it's more than 1 point, is no longer a function. So in this case, it's not a function, right? So not a function. All right. So if you look at B, we have a straight line and there's arrows at the end of these, right? So again, if you see the arrows, remember we're looking pretty much that it never stops. So if something never stops, that means if it's going to the left, right, we use an open parentheses to describe this domain. So it never stops going to the left, and that would mean it goes towards what we say negative infinity. Now, negative infinity is not a number, right? It's just an idea. It's going there. It's always increasing. It's never stopping. And then the same way if we're going to the right, you'll notice it never stops going to the right. So we're going towards positive infinity. So in this case, this would be the domain of the graph. And then the range, again, since there's arrows in both of these going up and down, so that means that the range is going to be the same. It's going to be negative infinity to positive infinity. And again, if you use a vertical line test, if you draw a vertical line anywhere on the graph, if you notice, it only touches one. So this one is a function. So the graph is a function. All right. So on question C, it's kind of the same thing, but now you have something different right there. If you notice, there are closed circles at the end. So that means that we have a stop. We have a start and a stop. So the domain here, the domain would be, again, we use a square bracket because that includes the endpoints. And then if you notice, we're at negative 2. And then all the way to the right, we stop at positive 4. Close bracket again. The range would be pretty much the same thing, close bracket, because it has closed circles. So here we're going from negative 4, which is our lowest value. If you notice, it's negative 4. And then our highest value happens to be positive 2. All right. And again, this one, if you draw a vertical line, again, it would pass the vertical line test. So the graph is a function. All right. And then let's look at the last three right there. D. So in this case, this shape has those two, but if you notice, it does have kind of like a maximum value right there on the top part, right? Like if you see a little part of the mountain, it has maximum value. So here, let's first look at the domain. So the domain of this function, if you notice, has arrows going towards the left and then going towards the right. So again, like we did in the previous one in part B, the domain would be pretty much the same thing right there. So open parentheses, we're going from negative infinity to positive infinity. And then the range. So the range does have a start value. So we would use a closed bracket again because it's part of the curve. And then the highest value goes to is positive 4, and then it goes down from that, right? So we would say positive 4, comma, and then infinity. Negative infinity, I'm sorry. Or actually, I have to write it backwards. So we're going from the bottom up. So that would be from negative infinity to the maximum value, which is positive 4. And again, if you draw a vertical line, it passes a vertical line test. So we can say this is a function. All right. And then looking at example E right there. So we're going, again, let's look at our domain from, if you notice we have closed circle, well, we don't have closed circles at the end, but it's still continuous line right there. And then this one, it looks like it's at 4 farthest to the right. So we're going from positive 2 to positive 4. And again, close brackets because it has closed circles. And then the range in this case would be the lowest value, which is starts at negative 3. Again, has the closed brackets because it's a closed circle. And then all the way up to positive 2. But now in this one, if you do draw a vertical line on this part of the graph, you'll notice that it intersects at 3 values. So this one is not a function. All right. And then the last part right here, we have pretty much a starting value right there. It should be a closed circle, and then we go to the right of that. So here, if you notice, that's the center, right? 0, 0, the origin. So here we can say the domain starts, that would be a closed circle, so a closed bracket, and then at 0, and then since we never stop going to the right, it would be positive infinity. And then the range, which is what's the lowest value. Now, if you notice, there's nothing lower than positive 3 here. So we would also say positive 3, close bracket. And then in this case, this graph is increasing. It never stops going up. It goes slowly up, but it goes up. So that would be positive infinity. And then if you draw a vertical line, you'll notice that again, in this case, this one will be, this is a function.